Token-saving tools for coding agents promise to cut waste. A 30-minute session can burn 118K tokens on CLI output alone. 7 tools promise 60 to 90% savings. Do any actually lower your total bill? Which tools reduce cost without degrading the information the agent needs? That is the question every developer using coding agents is asking right now. Most numbers are self-reported by the developers who built the tools. They tested on their own scenarios using their own methods. Today we use only verified measurements and independent benchmarks. These tools attack 4 different sources of waste in a coding agent session. Understanding which layer each tool targets is the first step to evaluating them fairly. CLI compression targets shell noise from Git, cargo test, and kubectl output. RTK, Snip, and token saver work here. Context compression targets what the model actually reads. Headroom and tamp compress the context window. Indexing avoids repeated reads. Code context engine indexes your codebase so agents search instead of rereading files. Evidence extraction pulls only relevant facts from tool output. Squeez is the only tool here with peer review. These tools are complementary, not substitutes. You can run RTK to compress CLI output, CCE to index your codebase, and Headroom to compress the context window. They stack without conflict. The critical gap is evidence quality. Most savings numbers come from the builders, not independent testers. Vendor benchmarks test chosen scenarios. Independent studies use different methods. Direct comparison is misleading. No common benchmark exists across all 7 tools. We normalize conceptually instead. RTK is a Rust CLI proxy claiming 60 to 90% savings on CLI output. Independent measurements show 48% average across 126K real-world commands, half the lower claimed bound. Recovery loops documented in issue 32 partially erase savings when lost information forces reruns. Headroom is a context compression layer with type-specific compressors for JSON, code, and prose. 15 to 20% on coding agents, 60 to 95% on JSON-heavy workloads. CCR makes compression reversible. The Dasein SWE benchmark found 1 more task completed, but with more tool calls and longer runtime. Squeez is a fine-tuned 2 billion parameter model extracting relevant evidence from tool output. Peer-reviewed paper. 0.86 recall, 0.80 F1, 92% compression across 11,000 examples. Measures single tool pruning, not end-to-end agent performance. We do not know how errors compound. Snip is a Go CLI proxy with declarative YAML filters for 132 commands. It is lightweight, runs locally, and requires no LLM calls. No independent measurements exist yet, so the claimed 60 to 90% savings remain unverified. Token Saver uses 36 specialized processors with deterministic, no LLM compression. It claims 60 to 99% savings. The deterministic approach means no LLM overhead, but it cannot adapt to content variations the way a learned model can. No independent data exists. Tamp is an HTTPS proxy compressing both requests and responses through a configurable pipeline. White paper reports 52.6% input compression and 60 to 70% combined. A/B methodology. Code Context Engine is an MCP server indexing code bases with tree sitter. 94% savings on fast API across 20 queries. The hidden cost is recovery loops. Lost information forces reruns, costing additional tokens that erase savings. Because these tools attack different layers, most combinations are complementary. RTK plus CCE plus Headroom stacks cleanly. Evidence quality ranges from peer-reviewed research to untested claims. Squeez is strongest. Snip and Token Saver have no data. For CLI waste, RTK or Snip. For context, Headroom. For indexing, CCE. For extraction, Squeez. Each tool has a clear winner in its category. Still missing from the evidence base. Independent head-to-head comparisons across all 7 tools, end-to-end cost data showing actual provider bills and recovery loop frequency measurements. Until these exist, the best approach is to test on your own workload. These tools genuinely reduce context waste, but measure total cost including recovery. No single tool solves everything. Freeze one task. Run 5 pairs with and without compression. Measure provider usage. Calculate cost per successful task.